It's my recommendation to do this lesson on graph paper because we're going to be graphing and solving quadratic inequalities. So basically you're going to be graphing a parabola, and then you're going to be shading some region so that you don't just have, two solutions or one solution. You have a whole area that's been shaded that includes all of your solutions. All right, so your essential question is, how do you solve quadratic inequalities by graphing? And you're pretty good at this. You've done a whole bunch of work with inequalities in your past. So now it's just, can you actually graph the quadratic equation? And then can you also shade the correct region? Okay, so I don't think there's much to really define here. I guess I can define what a solution is. It's basically going to be all points, and your points are x and y coordinates, that make the inequality true. And from your previous experiences with inequalities, you'll know that it's usually, or it's always, a shaded region. So you might also want to have some colors out. I'm going to use some highlighters for maybe not the first example, but definitely for the second example. So our first example is to basically graph. So we are graphing y greater than x squared minus 4x plus 3. Okay, so first of all, the first thing you want to do is you want to graph these things. Okay, so in order to graph this, we have to go through all the steps. It's in standard form. Can I potentially factor it? If I can't factor it, maybe I want to use quadratic formula to find my x-intercepts. Maybe then I also might want to find or use negative b over 2a to find my vertex, the x value of my vertex. So I have a lot of options here. I believe that this can be factored. So the first thing I'm going to do is I'm going to set this y equal to 0, and I'm just going to set it up like an equation. So that way it's easy for me to solve and get my x-intercepts. So factors of 3, that would give me 4. Well, that's just 3 and 1. So in factoring this, I'm going to end up with an x and an x for my first two terms. My last two terms are going to be 3 and 1. And in order for them to become a negative 4, well, they're both going to have to become negative, right? And that'll give me that negative 4x. So both of these are negative. Okay, so that's just me checking here, which also makes sense because negative 3 times negative 1 would give me that positive 3. So it all checks out. So now I'm going to use that zero product property where I set each factor equal to 0, because when y is 0, that means that we're on the x-intercept. So these are going to be my two x-intercepts. So to graph that, I'm going to, first of all, plot. Now it seems to all be in the positive direction here, right? Positive x's, so I need maybe more on the right than I do on the left, but okay. So plotting my x-intercepts, I have one at 1 and one at 3. Okay. This thing, if I look back at it, it's going to open up because a is positive. So now I need my vertex, or my minimum, right? My lowest point. Well, my vertex is located halfway between my x-intercepts. So I know that my axis of symmetry is when x equals 2. And I know that I'm going to end up with an output somewhere. And the way I'm going to figure that out is by plugging it in. So thinking of like in terms of an xy chart, I'm going to plug in 2. And when I plug that into my equation, let's see, I'll have y equals 2 squared minus 4 times 2 plus 3. So that's 4 minus 8 plus 3. Negative 4 plus 3 That's going to give me -1. Okay, so my output, my vertex, is basically 2, -1. Okay, now thinking about, am I going to draw a solid parabola or am I going to draw a dotted parabola? Remember, you need to look at your inequality sign. So it's going to be dotted because there's not an equal sign there. There's a greater than sign. So this becomes a little bit challenging. Oh, and you know what else I would do at this point? Because it looks to me like I'm really close to my y-axis, I'm actually going to figure out what I would get if I plugged 0 in for x. So that way I have my y-intercept. So if I do that, let's see, where else can I write? How about over here? I will get 0 squared minus 4 times 0 plus 3. I could have just done that in my head. So I'm basically going to get an output of 3, which tells me that my y-intercept is up here at 3. Okay, now I feel better about graphing this. And I could even say, well, then that means if I go one more over, this will also be a point. Okay, so I'm going to do to the best of my ability, a dotted parabola. These can get kind of tricky. Okay, now this says y is greater than. So I'm going to look at my y values, right? And I want all y's that are greater than, well, first of all, than this y-intercept. Okay, so I want everything that's going to be shaded basically above this parabola. So, or you might think of it like as inside. It's a little bit tricky that way. But I'm basically shading up. Okay, and so all these solutions will work. Okay, one way to definitely check this is to take any point that's in here and plug it in. Okay, so that would be a way to double check that you've shaded the right way. Let's do another example. This one I am going to use color for, because we're going to do two inequalities, so a system of inequalities now. So we have y greater than or equal to x squared minus 9. And I'm going to write it over here because I'm going to factor and work with these. Y less than negative x squared minus x plus 3. Okay, so for this one, I notice that it's a difference of two squares. Okay, so I'm going to, first of all, I'm going to create, I'm going to put this in standard form, put a 0 here, make it an equation so it's a little bit easier to work with. Okay, we're just finding our x-intercepts right now. Okay, and then later on we can go back and shade. So, realizing that this is a difference of two squares, this is going to be x minus 3 and x plus 3. Hopefully you're getting better at this by now. Which tells me then that I have two x-intercepts. One of them is going to be 3 and the other one's going to be negative 3. You could have also used square roots on this. I just for some reason have a tendency to go to a difference of two squares because I like that friend so much. Looking over here, are there factors of 3 that will give me 1? It turns out there aren't. So, let me rewrite this as an equation. So instead, I'm going to have to end up using the quadratic formula in order to find my roots. And then I'll have to use the negative b over 2a to find the x value of my vertex. Okay? So I'm going to go ahead and find my roots now. And then we'll graph both of them. Yeah, let's do that. We'll graph both of them together. So, my a here is negative 1. My b is also negative 1. And my c is 3. Okay? So my x's then are going to be, well, negative b. So a negative negative 1 plus or minus the square root of b squared, which is negative 1 squared, minus 4 times a, which is negative 1, times c, which is 3, all over 2 times a, which is negative 1. Okay, there's a lot of simplifying to do here, so that's my next thing. So I've got a positive 1 plus or minus the square root, well, that becomes 1, and this becomes a positive 12. All over 2 times negative 1, which is negative 2. So final simplify here, I really have 1 plus or minus the square root of 13 over 2, and that's going to be a negative. It doesn't matter where you put the negative. Okay, so I think it's time to start graphing these two. So why don't I start by graphing this? I'll plot those points, and then we'll find the vertex. Okay. Kind of skip. I'm going to try and give myself some more room because I have more work to do. I probably don't actually need to go up this high, so I'm going to go a little bit lower. Something like that. Okay, starting with the first one. So I'm going to do different colors. So how about if I highlight this one in yellow, and I'll highlight my other equation in blue, and that way we can kind of keep them straight. Okay, so I'm going to start with the yellow one. So I'm going to plot those two x-intercepts. So there's 3 and -3. So my vertex is going to be in the middle. And again, it's opening up. So I know that my x value, my vertex, is on the y-axis. So now the question is, what's the output? Okay, so again, thinking to myself in terms of like an xy chart. If my x is 0, what's y? Well, if I plug 0 in here, I get -9. Oh, I need to go one more. So -9 here. Okay, so thinking about this, now that's a greater than or equal to sign, which means I'm going to have a completely solid parabola. Again, the hardest part is drawing these things, probably. Okay, so I know that in this parabola, I'm going to be shading up. Okay, and I'm going to go ahead and color this parabola yellow. Okay, the other side now. So the first question is, well, what the heck are these numbers? Well, this is x equals -1 plus the square root of 13. The square root of 13, I'm not sure what that is, so let me find my calculator. It is approximately 3.6. So these are going to be approximations, but 1 plus 3.6 over 2, -1, I should say. And then my other x value will be -1 minus 3.6 over 2. So this is going to be 2.6 over 2. And this is going to be -4.6 over 2. Okay, so I'm running out of room here. Sorry about that. So can I come over here and put my answers over here? So this x is going to be 1.3. And this x is going to be -2.3. Okay, so let me plot those x values. So 1.3, well, there's 1. I'll go a third more. And then -2.3, well, there's 2. I'll go with -2. I'll go a third more. Okay, now thinking about this equation, a was negative, so I know that this thing is going to be facing down. Now the question is, where is my vertex? So one way you can do that is you can take these two and average them. Okay, but working with decimals, a lot of you guys don't like to do that. So maybe the better way to do that is to actually say, hey, my x value of my vertex is -b over 2a. And you already have that information up here. So -b would be a -1 over 2 times -1, which will be positive, no, it's going to be -1/2. Okay, so at -1/2, that's the x value. And now I need to figure out what my y is going to be. So I have to actually plug that back in to my original equation. Okay, so that's what I'm going to do right now. So a -1/2, oops, a -1/2 squared minus a -1/2 plus 3. So let's see, over here I get -1/4 plus 1/2 plus 3. So you could turn that into decimals if you want. So that's going to be a -0.25 plus 0.5 plus 3. So that looks to me like it's 3.5 minus 1/4. That's going to be 3.25. Okay, so my vertex then is going to be at -1/2. Oops, sorry. 3.25. All right, so -1/2, and then up 1, 2, 3, and a little bit past that. Okay, and then as a reminder, this one's going to be dotted. Do my best. You can find these exact points of intersection on your graphing calculator. If you were to graph both of these equations and calculate the intersection, you could know where these points are. Okay? All right, so I'm going to be shading, let's see. So y is less than, so that means I want all y values that are smaller than where this thing crosses the y-axis. So I'm going to be shading down now. So the question is, where do the things overlap? Oh, wait, let's do a blue, just for fun, just to make this pretty. And I need to shade below the blue one, above the yellow one, so the area I end up shading is right here. And again, if you wanted to double check that this was true, choose any point in here and plug it back into both inequalities and see if they actually work.